Hello and welcome to lesson 4.3, differentiation rules for sinusoidal functions. Today we're going to look at sinusoidal functions, specifically the sine and cosine functions, and the fact that they are actually composite functions. So that means if f of x is defined as sine of g of x, then to find its derivative, well, you take the derivative of the outside function first, which is cosine, but you leave the inside function alone. Then you multiply by the derivative of the inside function. So you have to apply chain rule. Likewise, if your function is cosine of g of x, then its derivative is negative sine, leave the g of x alone, multiply by the derivative. And there you go. Okay, so let's practice some. We're going to also look at us blending some of the other rules together. So first of all, we're going to differentiate, find the derivative of f of x equals cosine pi x. So its derivative of cosine is negative sine, leave the pi x alone, and multiply by the derivative of pi x, which is just pi. Simplifying. And we get this. We can also use some of the simplification rules we learned in advanced functions to solve or simplify some of these problems. Okay, moving on along. Determine the derivative of the following functions. So these ones are going to start using other rules. First, realize that y equals sine squared x is the same as y equals sine x all squared. So to find its derivative, take the 2, bring it down, leave the sine x alone, reduce the exponent by 1, find the derivative of sine x, which is cosine x. Well, you might notice this as 2 sine x cos x. A formula you may remember from advanced functions. So this can simplify, if you'd like, to sine of 2x. Again, it's not necessary to change it to this form. It might help in some solutions. Okay, so let's try this one. To figure out derivative of f of t, find the derivative of t squared, which is 2t. Leave cosine t alone. Add t squared. Derivative of cosine t is negative sine t. So f prime of t. I'm only going to common factor a t out of both of these. I leave t. I'm left with 2 cosine t minus t sine t. Again, it's preferable to put it in fully factored form in case you ever want to find the zeros of the derivative. Okay, moving along. Here's another one. So to work out the derivative of this one, derivative of cosine is negative sine. Leave the x plus pi alone. Times it by the derivative of x plus pi, which is just 1. So the derivative right here is 3 sine x plus pi. Now, this one we could actually simplify. I'm going to simplify so I get a different solution, because it would be a little easier to work with. Okay, just so you guys remember, sine of a plus b is equal to sine a cosine B plus sine B cosine A. Okay, so this is sine x cosine pi plus cosine x sine pi. For those of you that need a refresher, cosine pi is -1, sine pi is 0, so our derivative just turns out to be -3 sine x. Et voila. Okay, next one. Ooh, more complicated. Okay, notice that we have one function here being multiplied by another function. This cosine squared has a squared piece on it. The 3x has got a 3x inside the function. So our derivative, well, let me write it using product rule. So I'm going to work out the derivative of 2 sine 3x. And I'm going to multiply by cosine squared x. Then I want to add 2 sine 3x. And I would like to work out the multiply of cosine x squared. Okay, so let's work our derivative out. So this will be 2 cosine 3x times 3, leaves the cosine squared x alone. This time I leave the 2 sine 3x alone. Bring the 2 down. Keep the cosine x inside. Find the derivative of cosine x, which is negative sine x. There's my derivative. Okay. Is there anything common that I could factor? You could simplify first before you factor, but that's an option. Let's see, there's 2 that's common between all of them, and a cosine x that I can see. I don't think there's anything else. So this leaves me with a 3 cosine 3x cosine squared x minus a 2 sine 3x sine x. And there we go. Oh, sorry, my apologies. Made one small error. This isn't the cosine squared x, it's just a cosine x. Very good. Okay, moving right along. Last one to try to work out. Let's try to find the derivative of this. So we have a squared inside the sine function, but we also have a t plus 3 pi also inside the square function. So I'm going to rewrite this first. Oops. H of t is equal to 2 sine t plus 3 pi. The sine of t plus 3 pi is squared. Okay, so derivative of this, I'm going to have to use the chain rule twice here. Okay, so 2 times 2 is 4. Leave the sine t plus 3 pi in there. Reduce that exponent by 1. Find the derivative of what's inside, which is just cosine of t plus 3 pi. And then, from there, derivative of t plus 3 pi is just 1. Not so bad. Okay. Let's reduce or simplify. So 4 sine t plus 3 pi cosine t plus 3 pi. again, because I can, I'm going to use my rules. I'm going to remind you of this one this time. This is cosine A, cosine B, minus sine A sine B. Again, if you have not memorized these formulas, it might be a good option to start memorizing them, because you're going to have to use them for university level mathematics. They expect you to memorize these things. Okay, so let's simplify. So this is going to be sine t cosine 3 pi plus sine 3 pi cosine t. This one's going to be cosine t cosine 3 pi minus sine t sine 3 pi. Okay. I'm going to write this one this way. This goes to 0. So those two values are actually 0. Cosine of 3 pi is -1. So this turns out to be 4 negative sine t times negative cosine t, which can be written as just 4 sine t cosine t, or if you wish, you can also write it like 2 sine 2t. Because 2 sine t cosine t is a double angle formula for sine 2t. And there we go. Thus concludes our lesson.